All right, so in this video, we're looking at homeostasis and how our body uses the skin for various processes in keeping the body stable. Again, homeostasis is the act of keeping a stable internal environment. So again, still in chapter 6, the integumentary system. And in this video, we're going to be covering slides 29 through 34 in our PowerPoints. So skin functions, as it says. Skin is versatile and vital for homeostasis. That's what this video is going to be about. It is a protective barrier. We talked about this in lab. Harmful substances. All the time you're going to have things trying to get in to your system, and it does such a good job that you don't realize it until it gets taken away. So if someone has a third-degree burn over any larger part of their body, they have to live in a sanitary environment until it heals, because anything can really cause you death. Oop, did not mean to have that squibble like that. But anyway, UV radiation, we talked about that in a previous video, how the melanocytes are going to produce melanin to help protect you. Microorganisms, it's protecting against those, and water loss. It is for sensation. Again, we have some nerve endings that we've looked at in lab, tactile and Packian, or Meissner and Packian, and we also in here looked at those tactile discs that are on the stratum basal. And so they're constantly monitoring our surroundings. We can, for touch and pressure and temperature and pain. We can excrete some wastes through the skin. Again, that is not necessarily a normal thing, but that is on any large scale, I should say, but it is something that does happen. This is where we're going to produce vitamin D. The sunlight is going to help create this chemical, which is needed to absorb calcium. And regulation of body temperature, which we've looked at many times before, but that capillary bed that is in the dermis is going to be controlled. It's going to either vasodilate or vasoconstrict in order to put the blood up to the surface if I'm warm, so that the sweat, when it evaporates, pulls the heat out and cools me down. Or they vasoconstrict, which means it's pushing the blood deeper into my body to protect it from losing that heat. So heat loss is a very big thing. So, or in temperature regulation and heat loss again. So any slight change in body temperature can disrupt, as it says, disrupt rates of metabolic reactions, which means can cause disease. That can be a problem. The set point is monitored, and you do need to know this. The hypothalamus, a little area in the brain, is where this thermostat basically is. And we're going to look at this when we get into the nervous system as well. Our body wants to stay close to 98.6, which is on the Fahrenheit scale, and that's what we think of it as. Again, 37 on the Celsius scale. I'm not going to test you on that, but it would probably be good to know, but that's just for your own benefit. Again, the skin plays a key role in homeostatic mechanisms by regulating body temperature. And again, it's going to do that through the vasoconstriction, vasodilation, and various things. But heat is the product of cellular metabolism. Again, in all of our body, and in particular our muscles, any activity, heat is going to be the biggest thing produced, whether it's for power, for muscle contraction, or whatever. The act of producing energy is going to have this energy that is produced be mainly, the majority of it is heat. So there's different ways that heat can be lost through the skin. Now, one is called radiation. Now, this just means it radiates. Now, this is, it says, the primary method. If you touch, and we're not going to get into the physics of this here, and this one chapter does kind of bother me because there's a lot of things. It's not, these aren't real easy things to understand, and you have to have kind of an understanding of certain physics. For instance, the second law of thermodynamics is called entropy, and it's just, there's different ways it's stated, but basically it is about heat is always going to move from hot to cold, and that's what radiation and kind of conduction is going to both be kind of tied into. So radiation, infrared heat rays travel from warmer skin to the colder environment. But when you actually touch something, heat's going to move through conduction from warmer to colder. So if you grab a glass of ice water, what's going to happen is the heat in your hand is going to be pulled out towards the ice water. Your hand might feel colder, but it's not colder because the ice is colding. The ice water is making your hand colder. It's making it colder because the heat is being pulled out, and it's kind of an odd thing. I don't really want to spend much time on trying to explain the difference of radiation and conduction, but convection is all about the air. I do want you to know something about these last two for sure. Convection is all about the air. So if I'm sitting in a hot room and there's no air, it is so hot. But if I put a little fan in it, just the act of the air running across my body is going to cool me down, because it's going to pull heat from my skin into the air currents. That's called convection. If you have a convection oven, it means there's a fan in it that's constantly moving the air around. But the last one is the one I definitely want you to know: evaporation. This is what happens when sweat evaporates from our skin. It carries the heat away with it because it needs some kind of energy source to change phases. I am so sorry about that. Anyway, so that one, the evaporation, is the one I definitely want you to know. The little bit about convection is basically about the air currents. Convection is air currents, and as it moves through, that's why if you have a ceiling fan, it'll feel like it cools you down. So evaporation is the one that we think of through sweat. Now, the way our body regulates this, when body temperature rises, again, remember the hypothalamus is monitoring all this. So if the body temperature rises, I need to cool us down. So our body needs to cool us down. So 98.6 is our set point. 98.6, all right? So all of a sudden, my temperature starts getting higher. So I start warming up. My dermal blood vessels are going to vasodilate. That means I'm pushing my blood to the surface towards the skin. And as that does that, the sweat glands are going to be activated. And so they're going to produce this watery fluid called sweat on the surface of my skin. The heat is going to cause that water to want to change from a liquid to a gas. And in order to do that, it needs an energy source. So it pulls the energy from the heat of the blood that has been put up to the skin. It pulls the heat out of it. That cools you down. If, on the other hand, I start getting colder, and I'll use blue for this, I'm going to do kind of the opposite. Again, still the hypothalamus is the thing monitoring it, but now I'm going to vasoconstrict those dermal blood vessels. I'm going to squeeze the blood from the surface of my body and push it into the deeper parts of my body. Sweat glands will become or stay inactive, but in this, I'm going to start causing my muscles to start contracting randomly, which we call shivering. And again, in the act of contracting a muscle, the majority of the energy is released as heat, so that hopefully is going to cause your temperature to raise. So hopefully that makes sense. This is a little picture that shows the flow chart of it as it goes around. Here, it kind of giving you the whole way it goes through, and then again on this side, we're looking at the cold as it happens. So anyway, I'm not going to go through all of this again, but this is what we just kind of talked about. The last little bit is talking about what happens if things go a little bit haywire. We can either get too hot, which is hyperthermia, or we can get too cold, which is hypothermia. And then let me make sure I change that there. Hypothermia. So if it's too hot, abnormally high body temperature. Now this is something that we here in the Southeast have to kind of be concerned about, because it can happen, and it can happen really quickly. What ends up happening is, in areas like the Southeast, it is very humid. So if I'm trying to take, and that's my skin, I've got this little drop of blood, and I'm wanting to put, or drop of water, sweat, and I'm wanting to evaporate it into the air, The ability of that to evaporate into the air is directly connected to how much water's already in the air. Humidity is the measurement of water in the air. So if I'm in an area that has high humidity, this idea of sweating doesn't work real well because there's the air's already full. And so the sweat cannot evaporate, as it says here, and then that's going to cause my body to start overheating because I can't use this mechanism to cool down. And so this has a couple of things to watch out for. First, your skin will go from sweating a lot to all of a sudden just becoming dry, right? You'll feel weak and dizzy, and you'll generally start feeling nauseous. And you know, if you have any of these, if you're outside around here and you have any of these, make sure you get to somewhere shaded and get some air going, a fan, so you can get some of that that conduction cooling, the air going by you. But you know, a headache is another thing you'll feel, and you'll have a very thin and rapid pulse. Now, if this ever happens, this is what you need to do you need to get medical help quick because this is a very dangerous situation. But I would take a cold, wet towel and I would put it around your neck, in particular the back part of your neck and then down around where your carotid arteries are. Because the first and foremost thing you want to protect is your brain. So you want to try and make sure that the blood that's getting up to your brain, it has some way to cool. You also want to put ice packs or very cold damp towels in the axillary and groin region. Those are the areas where some major arteries are very superficial, so that can help you cool down. But this is a dangerous situation. Now, just to kind of do a flip side, if you've ever been to the Southwest, it can be very dangerous. You know, you've heard people say, well, it's a dry heat. You know, it's 120 degrees in Las Vegas, but if there's a breeze going, it feels great because the air's dry. The breeze, which is conduction, is going to cause the sweat to evaporate that much quicker. And since the air's dry, the water's going to want to evaporate really quickly, so you cool down real easily. But here's the rub with that. If you're in an area that's dry heat and you're sweating, you can dehydrate very quickly and not realize it because the sweat evaporates so quickly. So that's just another little flip side. Now, on the opposite side of the temperature gap, we have what we call hypothermia, where we get too cold, the body temperature drops. Now, first thing is you're cold, your body's going to start sending signals. And again, the hypothalamus is the place that's monitoring this. But it'll start sending signals out to skeletal muscle to start contracting and relaxing, trying to produce this heat to warm you up. But in general, if you get somewhere that you're going to suffer from hypothermia, you know, this is going to last for a little bit, but you're going to start succumbing to it. Now, this is kind of the weird thing to it. And I don't want to make it sound like this would be a very, this is a way to die because I don't want to give any ideas about that. But you start getting kind of confused. You will start feeling sleepy, and your reflexes will start slowing down until you finally lose consciousness. You black out. Now, we probably all, even if here in the Southeast, it gets cold enough where if you're outside, you'll notice that you'll start having problems like bending, making a fist or, just trying to make movements become harder. It's not as quick. It's not a rapid response like it normally is. And that's kind of the idea. And it basically just shuts everything down. It slows everything down till finally it just stops. So that is hyperthermia, too hot, and hypothermia, too cold. All right. That is that for this video. And I think we have one more video to make for this chapter, and we're moving on. Take care. Have a great day.